So what's up, guys? Sometimes there is a need to determine how acidic or alkaline a substance is. For instance, to determine if a sample of water is safe for drinking, we need to determine its level of acidity or alkalinity. This necessitated the invention of a scale which serves as a reference or basis on which the acidity and alkalinity of different substances are compared. This scale is known as the pH scale, of which we have learned previously. In this lesson, we will focus on the formula which can be used to determine the pH and pOH of a solution if its hydrogen or hydroxide ion concentration is known. First of all, the pH of a solution can be defined as the logarithm of the inverse of hydrogen ion concentration of the solution to the base of 10. In other words, it can be defined as the negative logarithm of the hydrogen ion concentration of the solution to the base of 10. Mathematically, the formula for calculating pH can be written as pH is equal to log inverse of hydrogen ion concentration to base 10, or as minus log hydrogen ion concentration to base 10. In the same vein, the pOH of a solution is equal to the negative logarithm of the hydroxide ion concentration of the solution to the base of 10. You may wonder why we have a negative symbol in these formulas, or why the inverse of hydrogen ion concentration is used. Well, you need not wonder for long. The reason for this is to avoid getting a negative value for pH or pOH. The pH scale has only positive values which range from 0 to 14 as shown here. So, the use of a negative logarithm or inverse of hydrogen ion concentration ensures that our calculated pH and pOH values fall within the range of 0 to 14. Also, we learned earlier that the pH value of a solution does not only tell us how acidic the solution is, it also tells us how basic or alkaline it is. In fact, the more acidic a solution is, the less alkaline it is. Conversely, the less acidic a solution is, the more alkaline it is. This means that the hydrogen ion concentration of a solution is inversely proportional to the hydroxide ion concentration of the solution. If we remove the proportionality sign and add a constant 10 raised to the power minus 14, we have this equation. We have chosen this constant because the ionic product of water is 10 raised to the power minus 14 moles square per dm raised to the power 6. Therefore, the product of the hydrogen and hydroxide ion concentration will be equal to 10 raised to the power minus 14. If we apply our knowledge of logarithm to this equation by taking the log off both sides, we will have negative logarithm of hydrogen ion concentration plus negative logarithm of hydroxide ion concentration equals to 14. Having already established that pH is equal to negative logarithm of hydrogen ion concentration and pOH equals negative logarithm of hydroxide ion concentration, we can see that this is the same as pH plus pOH equals 14. This means that we can determine the pOH of a solution if we know its pH. The key points you need to remember from this lesson include: the pH of a solution is the negative logarithm of the hydrogen ion concentration of the solution to the base of 10. The pOH of a solution is the negative logarithm of the hydroxide ion concentration of the solution to the base of 10. The product of the hydrogen ion concentration and hydroxide ion concentration is equal to 10 raised to the power minus 14. pH plus pOH equals 14. I will see you in the next lesson.